Okay, so I said we want to keep in mind other formulas that we might possibly run into. We have a formula for a plus b squared. What about a minus b squared? And the answer is, it's really the same thing, because a minus b squared is a plus minus b squared. So we could even use the same exact formula. What do we know? We know that this would be a squared plus 2ab, but we have a minus b here. And we replace the b in our last formula with a minus b. So what do? We get this formula, which is equal to a squared minus 2ab. And of course, a negative times a negative, that gives us a positive. So now we have this formula as well. So let's write our two formulas side by side. A plus b squared equals a squared plus 2ab plus b squared, and a minus b squared is equal to a squared minus 2ab, but again, plus b squared. Of course, if you know this one, you also know this one, because this is how I can get it. There's one other formula, which is actually kind of important. And it comes, what happens instead of taking two of these, which would give us this, and two of these, which would give us this? What would happen if I took one of each? If I'm multiplying, it doesn't matter the order. So what happens if I just take a plus b times a minus b? What would we get? Well, we'll take the first two terms. Now let's take the outer terms. We have a times, I'll say plus a times minus b. We have the inner terms. That's going to be plus ba. And let's take these two last terms, minus b squared. And what do I get? Well, ba is the same as ab for our purposes. And look, that simplified rather nicely down to that. So a plus b times a minus b happens to be equal to a squared minus b squared. So, very important rule for us to remember, maybe more so than the others. And why is that? Well, because this thing on the left equals this thing on the right. I'll say that again. This thing on the left equals this thing on the right. We multiplied this and we got that. But that means if we ever encounter anything like this thing on the right is also equal to this thing on the left. So if I encounter something that's, say, of this form, well, you might say that's not of this form because this doesn't have a square, right? But I could always rewrite this as x squared minus 3 squared. I can go from this on the right to this on the left. So this would happen to be equal to x plus 3 times x minus 3. Now, that's going to be useful because what we just did is we wrote this difference as a product. And products are very nice for a number of reasons, especially if we're trying to set things to 0. So if I want to know when this is 0, it's going to be a lot easier for me to see when this product is 0. Because a product is only going to be 0 if one of the two pieces are 0. And it's really easy for me to solve x plus 3 equals 0 or x minus 3 equals 0. So this formula for a difference of squares is going to come in very useful. So that's a good one to really remember.